Hi everybody. This was requested problem 43 from homework 6D. So this is chapter 6. I'm going to go through this actually really quickly. I did this in class in period 6 already. Okay. So it says here, a satellite A orbits a planet with a speed of 10,000 meters per second. Satellite B is twice as massive as satellite A. So first off, there you go. There's velocity of A is 10,000 meters per second. But then they told me the mass of B, so that's what I got here, is twice the mass of A. So I want to write down that relationship. That's a good relationship to know. And then also they say that it orbits at twice the distance. So basically they're saying that the orbit radius of B is twice the orbit radius of A. So that's another thing that I would write down as something that's useful and that I would know. All right. So another thing you want to do often is draw a diagram. So I drew my planet right here, and then the two orbits. So the inner one is orbit A. So you got the velocity of A here, and then the gravitational force, which is causing that circular motion orbit. And then you've got the velocity of orbit B. The outer ring here is the orbit of object B, satellite B. And so then there's the gravitational force from satellite B as well. All right. So next up, we always go with F net equals ma. I'm going to randomly decide that object B is my object, that satellite B is my object. So if I do that, well, the force that's acting is the gravitational force, and that's going to be ma. But it's a special type of acceleration, centripetal acceleration, so it's going to be v squared over r. I want to be careful. This is mb, and so this is going to be rb, and this is fgb. So we also found we got an equation now for the gravitational force, a universal law of gravity. It's m1, m2 divided by r squared. So I'm going to take all that and plug that in there. That's going to give me big G mass of the planet multiplied by mb divided by rb squared, which is going to equal mbv squared over rb. Should be careful. All this is B stuff. So, because B is my object. So, okay. And then, as I can see, the mass of satellite B cancels out. One radius cancels out here, and another radius, so that the squared cancels out over there. And now I'm left with big G is the mass of the planet divided by RB, which is equal to VB squared. So next up, I'm gonna halt here and then actually use this to do my ratio part. So I personally like to do the ratio way to solve these things. There are other ways to do it, but this works best for me. So I tend to say I'm going to take the ratio of this. So if I did all of this with satellite A, I would get step by step exactly the same thing. So it's the same force, just it's going to be the force of gravity from that's acting on object A. All of this would be the same. It'd be the mass of object A, the speed of object A divided by the radius of object A. I'd plug in the gravitational force. All those things would cancel out, and I get the exact same thing. So I'm going to use the result of that for object A. So it's the mass of the planet divided by radius A, which is the velocity of object A squared. And then if I take the ratio of these two, a couple things cancel out. That's interesting. So G cancels out and the mass of the planet cancels out. Those are the same. So I'm left with 1 over RB over 1 over RA. And I get VB squared over VA squared. All right, so there we go. I can simplify this fraction down by multiplying by the reciprocal. So I'm going to do that. So it's going to be 1 over RB multiplied by RA over 1. So there's that, RA over 1, and then equals VB squared over VA squared. All right, and then so basically I got RA over RB equals VB squared over VA squared. Multiply both sides by VA squared, I get RA over RB, and then multiply by VA squared equals VB squared. So let's see, VA is 10,000 So I'm just going to square all that. And then RA over RB. RB is twice RA. So I'm just going to replace RB with twice RA. So I got RA divided by twice RA. And then RA is going to cancel out, so I got a half. And then that's going to equal VB squared. So I'm going to take the square root of both sides at the end. So basically I have 10,000 squared divided by 2. Take the square root, and that's going to be VB. So I'm going to do that in my calculator here. So that is 10,000 squared divided by 2, and take the square root, and I get 7,071 meters per second. And there you go. There's my answer. Hope that helped. Thank you. Take care. Bye.